So as a quick update on the internals of the MCM I'm testing at the moment for the LTO 48 volt setup. Now this looks very complicated. Don't get too scared by that. Some of these things are extra just for testing purposes. So we have a BCM interceptor here. That's not necessarily required, although I probably would recommend one. It's a useful thing to have. And we have a IMA CNC printed circuit board here. So again, that's not necessarily required. But again, I would recommend that if you've got lithium so that you can get full use out of your system. So, two things we have got this board here and we've got this board here. So this is a very simple resistor capacitor network. And basically what happens is when the ignition is turned on, this relay energizes and this circuit is then powered. And this capacitor charges up very quickly to a simulated voltage of 154 volts, 155 volts. That's for the V pin, feeds off into the V pin there. So it has a resistor capacitor here because this has to simulate the bypass contactor operation and the charging of the filter capacitors, and then the main contactors will engage. So that's a very simple way of defeating that system. So that's what that does. And when you turn the ignition off, the 5 volt power is removed from this, and then the system can see that the capacitors are discharging. So that again simulates that function. So that's what that one does. So a very simple little circuit there for that resistor and this, the resistor capacitor network and the little relay here. Obviously this is all the prototype, so don't worry too much about all the mess. So the next bit is this bit here. So this is the high voltage fooling system. Now in order to fool the BCM and the MCM at the same time, we need to have a same voltage going to both units. So what I've done with this one, this is a 155 volt power supply. Basically it's 348 volts and a 5 or a 12, I can't remember what that one is. It's not necessarily, that might not necessarily be the final voltage. We might just make do with 348 volts, but anyway, that's basically it, and these are about $2 each, so the cost of that is not that massively expensive. So this feeds out HV, and to feed the BCM, what we've done is we've connected the output to the MCM HV connectors there. So it's feeding the MCM HV detection circuit, which is all underneath all this, and it also goes out of the normal connector here to the BCM. So the BCM doesn't actually have any connection to the battery at all. So this just goes to the voltage taps and the standard 10k BCM fooler. So this just goes to the voltage taps. So that gives us our HV. So the HV is faked completely, and the car has no idea what the actual battery voltage is. So that's what you then have to monitor using your LTO BCM, OBD2 CNC device. So this is one way of doing it. This is a very sort of I'm quite not sure quite what the word is, but this hacks the whole thing, and the car has no idea what the battery voltage is, or doesn't know how to work it out itself, and we're just telling it basically that it's 155 volts with this V-pin fooler here and an HV generator here to supply the MCM and the BCM. Now this does work, as I mentioned earlier on, although the test drives have been very limited because of CV19, so that's one approach. This is the hard hack approach, and it does remove a couple of features. So it does remove stuck contactor detection, etc. But if you're hacking lithium anyway, that may or may not be your biggest priority. But that's a very simple way of doing it. So the next question is, or one of the questions is, do we need the BCM at all? Now this is quite an interesting idea, and I am thinking about this a bit. So what happens is that the BCM sends information to the MCM on the BAT SCI data line. So it comes in here, this goes through the BCM interceptor in this case, and then comes out of the BCM interceptor and then into the MCM. Now there is another line called the MET SCI line, and that comes from the MCM, and that goes out to the BCM, and then it comes back via the BAT SCI line. So if we connected the MET SCI line outputs from the MCM directly to the input, so basically we change the program, obviously coding in here, so we just remove the BCM completely, connect the MET SCI serial data line outputs from the MCM to the input to the BCM interceptor, and then we basically send fake packets back via the BCM interceptor pretending to be a BCM basically. So this little tiny board here would then just pretend to be a BCM, and it would have our fixed voltage programmed into it, so that it's just telling the BCM that the voltage, telling the MCM that the voltage is always 155 volts or whatever we've decided to fix it to. So that's another possible way of modifying the system and also getting rid of the BCM. But the only problem with that is you then need some current detection and temperature detection. So probably it's not going to be something that's going to go too far forward, but it was an interesting idea, and obviously that's where the BCM replacer comes in, which is obviously a standalone system with the video screens, etc., that you've seen, which replaces the stock BCM and retains all those features that the BCM currently provides. So it's just basically thinking out loud. So going back to what we have here, the summary again then. So we have the V-pin pool here, which is a resistor capacitor network with a little relay, and then we have the high voltage generation, which feeds the MCM high voltage detection and the BCM high voltage detection. So that seems to work quite well. So that's where we are at the minute.